Hey, fellow mathematicians! Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we're here to suggest that mathematizing is not about mimicking or rote memorizing, but it's about thinking and reasoning, about creating and using mental mathematical relationships. That math class can be less like it has been for so many of us, and more like mathematicians working together. We answer the question, if you're not teaching algorithms, then what? Hey, Kim, I just got an email from Melissa Freeze, one of the two teachers in the podcast, two teachers in Texas. And she said, I've been listening to your podcast and I'm so excited. I've been teaching for 25 years and your podcast makes me think! Exclamation, 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 exclamation. It also makes me rethink so much of my teaching, unquote.
Oh, that's great.
Right? Super cool. So I'm honored that what we were talking about makes such an experienced teacher rethink her practice.
Yeah.
And thanks for having me on your podcast, Melissa. I had a blast talking to Melissa and Todd, the two teachers in Texas, on the Two Teachers in Texas podcast. Y'all, it was the March 31st, 2021 episode of that Two Teachers in Texas podcast. We invite you to go listen to it. We had some great conversations.
That's so great. I knew you were going to be on a podcast recently, but I'm super happy to hear that she listens to ours too. That's great.
Kind of
I can't wait to listen. So Pam, this week, we're going to begin a series that we think everyone's going to love, right?
Everyone.
We saw how well received the short podcast about fractions, decimals, and percents went. And we already expanded a little bit on my favorite, percents. And we want to take some time now to dive a little deeper into fractions for everyone.
So today we're going to start with some important information that if we kind of have in our heads and our understanding of fractions, decimals, and percents, especially fractions, then it will help as we then start with students, as we do things that are sort of building up for students. So we're going to talk about the 5 interpretations of rational numbers. So what are rational numbers? Rational numbers are things like fractions, ratios, decimals, percents. In fact, a rational number can be expressed as the ratio of 2 integers. So for example, 1/2 is the ratio of 1 to 2. 4/5 is the ratio of 4 to 5. And if I made one of those negative, then we could have the ratio of -4 to 5 and so on. So those are rational numbers. Consider for a minute the simultaneity going on in a fraction, things happening simultaneously in a fraction. You have the numerator, a number. You have the denominator, a number, usually a different number. And then you're asked to consider the relationship between those numbers. That's a lot to consider simultaneously. And not only the relationship between those numbers, but then we can consider the relationship between those numbers as a number. So there's just lots of things going on simultaneously. Susan Lamon, in her book called Teaching Fractions and Ratios for Understanding, helps us think about these 5 interpretations. In fact, that's where we got them from.
Yeah. I remember, Pam, I'm going to interrupt here. I remember the first time you ever talked about with me these 5 interpretations, and it was super important. So I hope everybody's going to really listen to these 5 interpretations.
Excellent. All right. So here they are. So not in any specific order. The 5 interpretations of rational numbers are part whole, measurement, operator, quotient, and ratio. Now, we didn't expect you to get all those down because we're actually going to dive into each of them right now.
Yeah.
And so we thought we'd start today by discussing these 5 interpretations of rational numbers. Kim, let's start with the most common interpretation in the U.S. That doesn't, by the way, mean it's the best one to start with.
Yeah.
It just happens to be the most common one. And that is the part whole way of looking at fractions.
Yeah, it's definitely the most common, right? And in elementary school, it's likely the only way that fractions are taught.
Yeah, no,
right?
Not good, not good.
So we can picture a typical task in school, in elementary school, right? Young elementary school, where there's a pre-drawn object or set of objects, and students are asked to shade in a fractional amount, right? So like a rectangle is already cut for them into 5 pieces.
And 5 equal pieces, right? It's already cut into 5
Everything's done for them. And students are supposed to shade 4/5. Can you picture that? They might be asked to do the shading when they're told the fractional amount,
Mhm.
or they might be given an image with something pre-cut and shaded in and might be required to tell the fractional amount not shaded. That's really the only two things that they're asked to do.
So consider the development of mathematical reasoning, y'all. Remember, there's counting strategies come first, and then we build on that to get additive thinking, and then we build on that to get multiplicative thinking, and build on that to get
Mhm.
proportional reasoning, and then functional reasoning. If a student is given that kind of task, so let's review the task. They've given a pre-drawn object that is pre-cut into equal sections,
Mhm.
and they're asked to shade 4/5. What kind of thinking would that student probably be doing? So I'm gonna act it out here. I've got this pre-drawn thing. It's cut into equal 5 pieces, and I'm supposed to shade 4/5. Y'all, I'm gonna count the total. Yep, there's 5. It says 4/5. I'm gonna count 4 and shade those 4, and I'm done. Like, that is the only thinking that's
Uh-huh.
happening.
Mhm.
Now, maybe I've given them that pre-drawn figure with it cut into 5 equal pieces, and 3 of those pieces already shaded. And now the instruction is what fraction is represented. Again, what kind of thinking is happening? They're going to count the total, write that down in the denominator, count the total that are shaded, write that down in the numerator, and they're done. Like, that's it. They are literally only using counting strategies in order to do those fraction sort of tasks at those young grades. What we haven't done is create some sense of what
Yeah.
4/5 means. We haven't had students like grapple with the idea of what 4/5 are, or even better, starting with 1/5 to help them think about 4/1/5 or 4/5. They're just using counting strategies. That's a problem.
Right. Right. So we need to actually help students create a sense of what a fraction means, right? So in this case, we're talking about 4/5. What does 4/5 actually mean?
Yeah, so we do need the part whole interpretation, but we need to
Yeah.
do so much more. So be richer, and not
Hmm.
only the part whole interpretation. In fact, we don't think maybe that you're going to don't start with the part whole. So we need to talk about how to develop this richer, deeper meaning. We're going to do that in an episode coming up. For now, let's talk about one of the other interpretations. And we're going to talk about the measurement interpretation.
Yeah.
So this is all about 4/5. We're going to use 4/5 over and over again. This is all about 4/5 being thought of as 4/1/5.
Hmm.
So in other words, it's all based on my share. If I'm sharing with 4 other people, so there's 5 people total, there's 5 of us, then how much do I get if we're sharing fairly? I get 1/5, right? That's my share. So then what does 4/5 represent? Well, that's 4 of them. That's 4 of those 1/5. It's almost like I said, hey guys, let's share this fairly. But you guys, you don't want yours? Okay, I'll take them. Cool, I'll take 4 of them. So then I get 4 of those 1/5, right? Hey, Kim, it's almost like we're sharing a chocolate bar, because you would always give me your piece, right? And you'd want me to give you your Skittles, because I'm the
Right.
chocolate and Kim's the sweet and salty. Okay.
Right. Hey, I like the way that you actually said that just now, right? You said 4 of the 1/5. Interestingly, that's how fractional amounts will be named in a lot of other countries, 4/1/5. So here's a teacher tip for you guys. If you're only saying the words 4/5 to describe that fractional amount, you can bring more meaning by also saying 4/1/5. 4/1/5. Try hard to alternate your use of those two ways, because 4/5 really is 4/1/5.
Absolutely. So now let's talk about your favorite interpretation of rational numbers, Kim, the operator meaning.
Yeah. Why is that my favorite? I don't even know. I love the operator meaning.
Yeah, what's going on there?
I think it's because it's actionable. It's in our daily lives
Mm.
and you do something with the fraction, right?
Yeah, that makes sense because you're a doer. All right, so give us an
Yeah.
example of what we mean by the operator interpretation of rational numbers.
Okay, I actually have a recent story. So my younger student is currently learning about the operator meaning of fractions and the representation of a fraction times a whole number, right?
Okay.
He's being asked to think about some quantity like 24 and then find 1/3 of 24. So he's literally thinking about 1/3 of something is going to be a part of that thing, right? He knows that he needs to think about the 24 into 3 parts, which is pulling on his understanding of division.
Nice.
And
Good
what's
connection.
even cooler about what he's doing right now is that it's a combination of the operator meaning and the measurement meaning. So he's being asked to think about like what's a fourth of 32. And he's thinking then about 3/4 of 32. So like if you know 1/4 of 32, that can help you with 3/1/4 of 32. I
Cool.
love that.
And that's the operator meaning, all
Yeah.
about thinking about, and the reason it's called operator meaning is because you're operating. It's
Yeah.
that action thing. You're finding 3/4 of 32. You're like feeling like you're acting on 32 to find 3/4 of it.
Yeah.
Cool. Super cool.
Okay. So the next one we're going to talk about is the quotient interpretation. Tell us a little bit about that one.
Yeah, so this is the one that I'm going to admit that I wrote, memorized. Now it's because I was sort of told it, like teacher said,
Mhm.
this is the thing, and I could use it in a very limited way. But now that I own it, whoa, like it's so powerful in so many ways. This is all about the relationship between fractions and division, or between ratios and division. Here's an example. So let's say that I'm sharing those 4 candy bars among 5 kids. Okay. So I've got 4 candy
Mhm.
bars and I've got 5 kids. Each kid gets, so you might want to pause right here. Just think about it. If I have 4 candy bars and I'm sharing them among 5 kids, how much of a candy bar is each kid going to get? Maybe even pause the podcast right here and think about if 4 candy bars are being shared among 5 kids. 5 kids are sharing 4 candy bars. How much does each kid get? In other words, we're thinking about sort of less than 1 candy bar, right? If it's 5 kids sharing 4 candy bars, they don't get a total of 1 candy. How much do they get? Yeah, they get 4/5 of a candy bar. So those 4 candy bars shared among 5 kids is equivalent to 4/5 of a candy bar per kid. 4 divided by 5 is 4/5. And if you
Yeah.
can see what I'm writing as I say that, then I would write 4 division symbol 5 is equivalent to an equal sign 4 fraction bar 5. Or if I said that in an opposite way, 4/5 is equivalent to 4 divided by 5. Now, the limited way that I used that was to find the decimal equivalent for fractions. So that's the way that teacher sort of said, here's how you do
Yeah.
it. If I was given 4/5 and the teacher said, like, find the fraction or find the decimal equivalent of 4/5, then I would say, oh, I know how to do that one. Yeah, I remember. Let's see, that was the rule where, yeah, we do division, right? And then I would
Oh,
have
yeah.
done long division. I wouldn't have
Ouch.
thought about. I know Kim's like, what? Yes, Kim, even for something
Oh,
like 4, I mean, it
yeah.
didn't matter the fraction, except maybe a half, 1/2, and fourths. Other than
Hmm.
that, like halves and fourths, I could have thought about in decimals. But other than that, literally all of them, I did long division in order to get their decimal equivalent.
Yeah.
But Kim, that's not how you would have reasoned about finding the decimal equivalent to 4/5. Tell us about
No.
that.
So I'm such a percents person. I think about percents more than decimals, really. And I know that 4/5 is 80%. So then I could go 80% is 0.8 or 8/10.
I mean,
And honestly, I kind of own that one, right? It's fifths. So that
yeah.
one's not,
It's funny though, but you're like, it's fifths, you just sort of
yeah.
say it like everyone knows fifths. I mean, not everybody knows fifths yet, but we all
Right.
can. We all can
Right.
think about fifths and we can reason about them enough that then they sort of become ingrained, kind of like Kim just went straight to 80%. Cool. So how about a number like you just admitted, right? You own fifths. So what if I give you one that maybe you don't own as much? How about something like 3/8? 3/8. How would you think about the decimal equivalent to 3/8?
Oh, so I actually own that one too. That's
Okay, all
37.5%.
right.
But if I didn't own that one, I could use the fact that an eighth is 12.5%, and then I could scale up times 3. So I know 1/8, and that will help me with 3/8.
Okay, so you know 1/8, but what if you don't
Yeah.
know 1/8?
Well, so 1/8, man. So I would think about a fourth is 25%. So an eighth would be 12.5%. Like I think a
Because
lot of us know a fourth. Yeah.
okay, all right. So if a lot
Can
of
we
us know a fourth is 25%, how did you get from a fourth to an eighth?
So 2/8 make a fourth.
Okay.
So then 2 12.5% make 25%.
Cool. So kind of thinking about the relationship between a fourth and an eighth.
Yeah.
If you know that an eighth is half of a fourth and a fourth is 25%, you do half of 25% to get 12 and a half. Cool.
Yeah.
So maybe you've done that enough that you just sort of own what 1/8 is. And
Yeah.
then you can scale that 12 and a half times 3 to get 37 and a
Yeah.
half. That's how you were finding the equivalent for 3/8.
Yeah.
You know what I tend to do a little bit? I don't really scale 12 and a half times 3. I think about a fourth being 25%. I know an eighth is 12 and a half. So I think about that 25 plus 12 and a half. That's how I get to the 37. Yeah.
Nice.
Thank you. I appreciate it. Okay. So how about a fraction like 3/25? Go.
Oh, so this is also a kind of operator and measurement meaning together, right? So I would think about 1/25 is 4%. So then
How do you, wait, how do you know that? How do you know 1/25 is 4%?
Because I'm thinking about 25 times 4 is 100.
Okay.
So 1/25 is 4%. And then 3/25, I would scale it times 3. So that's 12% or 0.12.
So you use the relationship between 4 and 25 being 100 to think
Yeah.
about 1/25 is like 4%.
Mm-hmm.
And then if 1/25 is 4%, then 3 of those 25ths is 3 times 4% or 12%. And then you got 0.12.
Yeah. 0.12.
Or 12 hundredths for those of you who are purists out there that we can use. 0.12.
Sorry. Sorry
No, it's okay, because if you remember our percent conversation, we said specifically that we think that we want kids to be able to say 0.12 and 12 hundredths.
Right.
I think that that's important. But they should also be able to say, by the way, 12 hundredths and 1.2 tenths. Anyway, we'll go on. Okay. Let's see. I think we're ready to talk about the last. Are we ready for the last one?
Yeah. Okay. So last one is going to be the ratio interpretation.
All right. So the ratio interpretation actually has come into our conversation already today a little bit when we were talking about 4 candy bars shared among 5 kids. That's a ratio of 4 candy bars to 5 kids. So that's kind of all we're going to talk about with ratio today. We're going to get into all of these a little bit more later. We've talked a little bit about each of the 5 interpretations, and what we want to emphasize today is that what's so interesting and important is how we actually shift back and forth between all of these interpretations as we solve problems with rational numbers. So Kim, let's dial in on that a little bit. Let's talk about the fact we've already kind of mentioned in some of what we did that we were using 1 or 2 or more of the interpretations, but let's actually get really specific about how we're solving problems and kind of shifting in and out of all of these interpretations with rational numbers as we're solving those problems. All right, you ready? So sure. I'm going to ask you a question, and as you solve it, I might have to help you pull out your reasoning. Like, right, you guys, after you've done something so often, it can be hard to kind of like think about your thinking, right? So Kim and I are going to work together on this. She's going to solve a problem, and then we're going to pull out the different thinking involved. Okay, so here we go. 8 kids are sharing 7 large candy bars. 8 kids sharing 7 candy bars. How much of a candy bar does each kid get? Now, listeners, before Kim just goes, you might want to pause here and you think about 7 candy bars for 8 kids. How much of a candy bar does each kid get? You might pause here, but ready, Kim, go.
Okay, so if there are 7 bars for 8 kids, I know they're not going to get a whole bar each. That's like my first. That's a great thought.
Yeah, great beginning thinking.
So it's going to be a fraction of a bar for each kid. So a thing I could do is take each of those bars and slice them into 8 pieces. And I have a whole bunch of 8th pieces. And each kid, after I dealt them out.
1/8 pieces. I'm going to interrupt you there.
Yep,
you said 1/8 pieces.
1/8 pieces. So I could cut each candy bar into 8 pieces, which would then be called 1/8. And I could deal them out. So each kid gets 7 1/8 pieces. So they'd get 7/8 of a bar.
Wait, where did the 7 come from?
Because there were 7 bars.
Oh, right. So they get an 1/8 from each of the 7 bars. So they get 7 1/8 pieces and 7 1/8 pieces. Okay, good. All right. I got it. Okay.
Or honestly, that might be something that I could see myself doing, with one of my kids, or I might just consider
before you go on, before you do another kind of way to think about it.
Yeah.
Let's pause on that first way that you just said, and let's see if we can parse out all of the different interpretations.
Oh, okay. All right.
So we started with 7 candy bars shared among 8 kids. That's ratio. Like we started with ratio. So the kids have to consider this ratio of 7 candy bars to 8 kids. And then you said, I'm going to cut each candy bar into 8 pieces, right? And so you're sort of creating those unit fractions. We call those unit fractions, those 1/8 pieces, kind of what's each kid share. If I just am sharing my 8 kids, 1/8, kind of created those. And that's kind of has to do with that measurement meaning that we're thinking about 1/8 a little bit. Well, at the end, when you decided that you had 7 1/8 pieces, if we kept going and said, so those 7 1/8, there's again the measurement meaning, turns into 7/8, then that's kind of thinking about sort of completing the measurement meaning, that I can think about 7 1/8 as 7/8. Does that make sense?
Yeah.
Okay. All right. I think maybe we're ready for you to keep going.
Yeah. So maybe what I would actually...
No, sorry.
Oh, you got more. All right.
Because we had 7. So we had the ratio of 7 candy bars to 8 kids. That's like taking 7 divided by 8 and getting 7/8 of a candy bar per kid. That's the quotient meaning. Bam! Okay.
Which is actually probably where I'd go straight to. And that's what I was about to say. If I'm considering that it's 7 bars divided by 8 kids, they each get 7/8 of a bar. And one of the things I didn't necessarily mention is that when if I'm in real life, right, I might think about it as 7/8. And I'm probably realistically, if I'm going to cut those bars, I'm going 7/8 for the first kid, 7/8 for the second kid, and then and continuing on 7/8.
Well, let's picture that a little bit, because I know what you mean when you say that. Instead of taking 7 1/8 and sticking them together, you guys picture that, an 8th from each candy bar, and then you're like handing 7 pieces to a little tiny 1/8 to a kid. Instead, you're thinking to yourself, if I already know that a kid's going to get 7 1/8 or 7/8, you're taking the whole candy bar. And you're like only hacking off 1/8 and giving the rest, the 7/8, the 7 out of those 8 pieces. Ooh, there's the part whole interpretation, to a kid, right? You give them the whole contiguous piece of candy bar. So instead of giving them all these little tiny pieces, you're like, since I know it's 7/8, I'm going to give them that whole chunk together. Except, Kim, if you do it that way, you've got that little 1/8 left over 7 times. So one kid's getting the shaft, right? One kid gets all those little tiny pieces. I mean, if you're going to do it that way. So at least everybody else got the whole, like kind of pieces together instead of kind of apart. Okay, so I think, so the only meaning that we didn't maybe talk about was operator, but you were kind of using operator as you said it was 7/8 of a candy bar. Like when you decided that they were going to get 7/8 and you had to like look at the whole candy bar and say, well, where is 7/8 of this candy bar? And you cut off that little 1/8 to give to the poor kid that gets all the little 1/8. but in order to do that, you had to have been thinking about the operator meaning of fractions. Y'all, the big point here is that it's the shifting back and forth, that it's using all of these interpretations. It's kind of like the optical illusion with the, if you look at it and you're like, do I see the old woman? Do I see the young woman? And it kind of depends on like what you're focusing on. It's not that they aren't both there. All of these interpretations could be there in a problem. It's just that you kind of focus on one or the other, which is so fascinating.
It is, right? It's so fascinating. We know that there's these 5 interpretations, and that's why it's so important that we don't just focus on part-whole relationship, even in the very early grades.
Yeah, and speaking of early grades, you are not going to want to miss next week's episode where we address ways to start building fractions with our youngest learners. So tell all of your colleagues who teach pre-K 2 or really any younger grade, but pre-K 2 students for sure, to check out next week's episode. Hey, and also remember, check out the March 31st, 2021 episode of the Two Teachers in Texas podcast, where high school history teacher Todd and 4th grade teacher Melissa and I do some great fraction work. Super cool. All right, remember to join us on #MathStratChat on Facebook, Twitter, or Instagram on Wednesday evenings, where we explore problems with the world.
Hey, if you find this podcast helpful, we would love it if you would rate us and give us a review. That way more people can find it wherever they get podcasts. And if you really wouldn't mind, we'd love it if you leave your Twitter handle and we can tag you.
Totally.
Don't forget that we're collecting your questions that you want answered. You can send those to at mathisfigureoutable.com, and we will tackle them in the upcoming episode.
Which will be so fun to get those questions in, because we are going to tackle your most asked questions in that upcoming episode. So if you're interested to learn more math and you want to help yourself and students develop as mathematicians, then don't miss the Math is Figureoutable podcast, because math is figureoutable.